Alright, welcome to another video on set. We're going to be considering set types or types of sets in this video. If you've not subscribed already, please do well to subscribe to this channel. Um, we really appreciate that. Actually, for set types, there are a lot of set types that exist. We're just going to pick out some that are very important, especially the ones you'll be working with in problems on set. But I'll just go through almost the major ones for now. You need to know universal set for a start. You need to know subset. You need to know empty set. Um, you need to know power set. Equal and equivalent sets are not very necessary for now. You need to know complement of a set, disjoint, and non-disjoint set. Most times you'll be using these ones I just mentioned while solving problems. The other ones most times are used for objective questions and all that. But if you still want me to explain those ones, I will. If you leave a comment on that. All right. So for this first part, I'll be explaining universal set. Now, universal set, we'll just call it the mother of all set. All right. So the mother of all set. You say the subset, that's the next one, we call it the child. Now for each of these, there are actually symbols to represent them. So for the universal set, most times you see the symbol U like this, or you can see the symbol something like this. Okay, so most times you see this attached to a Venn diagram or something. But like these symbols are used for universal set. Now, why do we say the universal set is the model of all set? Now, basically, we have different types of collections, like natural numbers is an example of a universal set because from natural numbers you can get other sets, you can get children from them, you can get prime numbers because natural numbers, 1 2 3 4 5 6 7 8 9, just like that to infinity. From that you can get um prime numbers, odd numbers, even numbers, just like that. And those children you get from them are called subset. So the symbol for subset is this, or could be this. All right. So these are the two major types of sets you need to know: the universal set and the subset. So understand that the universal set is the mother of all sets, and the subset is like the children, what you get from the universal set. Okay. So you'll be seeing when we solve problems, I'll bring out those very clearly. Now, the next we'll need to consider, you just need to know this empty set involves a set with no elements. So we can say no elements. This is for empty set, Well, now let's go to the major real type of sets you really be working on, like for real. A lot of them questions you see on set notation problems will contain these types of sets I want to talk about. Complement of a set. All right, so let's explain it very intricately. Understand that if you have any set, say K, now this is a set that has elements in it. So let's say we have elements like 1 2 3. Okay, and let's say we have a universal set somewhere U with elements 1 2 3 4 5 6 6 7 and on like, let's say all the natural numbers, but K says 1 2 3. Now complement of the set K has to deal with the symbol is written like this. Let me write it again. Complement of the set K written like this or like this, K prime. So this means all the sets, all the elements in the universal set that is not K. So most times I like to tell my students that anything that is not K, that's the complement. Or anything that is not that set you're looking for, or it's in a universal set, that's the complement. So you see that K is 1 to 3, right? Now, in a universal set, we have other elements like 4, 5, 6, 7. So all those ones that are not K gives you the complement of the set. So we can just say that the complement of K will be those ones that are not K. So it's not 1 to 3, but the remaining ones 4, 5, 6, 4, 5, 6, 7, and on like that. So this is the complement of K. So complement of a set is a set that contains elements in universal set but does not belong to that particular set you're looking for. You're getting the elements from. Okay, that's complement of set. So if they ask you in, for example, they say, let's give examples. I think to make it better. So let's say, for example, they give you the universal set is A, C, D. No, not that. I'll do the right A, B, C up to A, B, C, D, E, F, and on like that. And they say that uh, there's a set X having B, C, D. Now they say find X complement, or they can write it as X prime. It's the same thing. They are the same thing. So now, for you to be able to find X complement or X prime, you need to understand what the complement is. We already explained that the complement is anything in the universal set that it does not belong to that set. So the elements in universal set that does not belong to this set are A, E, and F, and on like that, because B, C, D are in the set. So X prime or X complement is equal to the ones that are in the universal but not B, C, D. So we have A, we have E, we have F. That is the complement of X. Okay, so I'm just going to set one more example, and I think we'll be through with complement. So if you have a universal set having integers -3, -2, -1, 0, 1, 2, 3, and on. All right, and there's a value R. A set R has values -1, 1, and 3. What is the complement of R over this? All right. So what is this? What is the answer to this? Now, from what we've explained to you, you should be able to get the answer to the question. So you just look for what is inside here that is not here. So in other words, we can just say that our complement is going to be -3 is in universal but not in R. -2 is in universal but not in R. 0 is in universal but not in R. 2 is in universal but not in R. And I think that will be it. So this will be the answer to the question. Okay, so that's how it works for complement of a set. Now let's go to another type of set. Power set. Very interesting set. Always very interesting though. Well, it's a type of set that deals with a collection of all subsets denoted by 2 raised by s. So it has to do with subsets of a set. Basically, all subsets of a set. And it's denoted by, I'm going to put it first in y 2 raised to power s, where the s signifies the number of elements in that set. So let's give an example. Let's say we have a set of A being A, B, and C. What is the power set? They're asking you for all the subsets that can come out from the set A. So In other words, to solve this, we understand that the number of elements is A, B, and C, that is 3. So signifying it as 2 raised by s, where s means the number of elements in the set, our power set is going to be 2 raised by 3. And we know that 2 raised by 3 is 8. So in other words, we're saying that the number of subsets we can get from the set containing 3 elements is 8. We explained before that the subset is children of the universal set, or children of a particular set. Now, from this set A having elements A, B, C, we can get the subsets as a list of them as 1 is A, 1 is B, and you can also get C, and you can get A and B. You can get that from this set. You can get AC also. You can get BC, all right? And we've covered almost all. We can get the set itself, that's ABC. And then finally, we can get an empty set. So naturally, if you count them, 1, 2, 3, 4, 5, 6, 7, 8. These are 8 subsets from the set of A where the elements are A, B, C. So in a power set, the empty set must be included. The empty set and the set itself must be included as part of the subset of that set. We're going to give another example, all right? Because it's a lot of talk here. So let's give another example. So let's say that you have a set where x is equal to a, no, we've used a before, is 1 and 2. Now to say, what is the power set? Or find the power set, or they could ask you the superset. Naturally, we know that in solution, a power set is denoted by 2 raised by s, and s involves the number of elements in the set. So the number of elements in the set is actually just 2, right? So we can say it is 2 raised by 2. And naturally, 2 raised by 2 is what? 4. So the number of sets we can and subsets we can get from 2 elements is 4. So x can have 4 subsets, meaning that we can, if you have to list them out, the arrangement will be starting with 1, then 2, then the set itself 1 and 2. And remember, we said the empty set must be involved as a subset of a power set, so the empty set. So this makes up 4 subsets of the set. Okay. One last example. If you have a set let's say how many subsets will a set containing 4 elements have? Now, if you look at this very clearly, you say how many subsets will a set containing 4 elements have? We already know that power set involves in the having all subsets of a particular set, or the number of subsets of a particular set. So if they tell us already that the subset and the set has four elements, and we already know that power set, let me use another. We already know that power set is denoted by 2 raised by s, where s means the number of elements. So since it has 4 elements, so it's going to be 2 raised by 4. And it tells us that if we multiply 2 4 times, we're going to have 16 subsets. So this will be the answer to the question, basically. Now, if you are given the set, maybe they tell us that the set is X, having elements A, B, C, and D. Now, from this, would you be able to list out 16 subsets? Because we just know that, yeah, it's going to be 16 subsets that you get from 4 elements, knowing very well the formula is 2 raised by s. But will you be able to list it out? From all we've been doing, I think you should try it out to see if you can really list them out. Remember that the set itself must appear, and then the empty set must appear. That will complete it for you. All right. Okay, so if you can do that, then I think you're good to go with power set. But let's move on to the next type of sets you need to know. Disjoint set and non-disjoint set. Now this one is just going to be very quick. We're just going to explain it quickly. What you need to know about disjoint set is this. This is disjoint set. If you have the intersection between two sets, A and B, the formula is going to be empty. This statement here means that there are no common elements between A and B. We already learned before that intersection means common elements, right? So, and we already learned that this, did we learn it? Okay, did I tell you? Yeah, but now I'm telling you that this means, actually means empty or no element. Yeah, when I was explaining empty sets, I think I said something about no element. So when it says the common element between A and B is equal to empty or equal to no element, we know it as disjoint set. So any disjoint set has no common element. That is the idea. So we can say disjoint set, no common element. But the major reason why I started with the equation is so that you know the equation for it. But what about non-disjoint set? It's just the opposite. The formula is if you have A intersection B, it is not going to be equal to empty set or empty, meaning that they are common elements. At least there should be one common element between the two sets. So that is non-disjoint set. It's the opposite of disjoint set. So anytime you see slash on any symbol, it means that it is not. All right. So A intersection B is not equal to 0, or it's not equal to no element. So it means that non-disjoint set has at least one element. That's the idea. All right. So I think that's everything you need to know about set notations, and we've talked about set notations, right? We've talked about the types of set. The remaining thing we're going to work on is solving set notation problems. That'll be the next video.